So if this f composed with g is equal to x, if this is equal to x, then we move to the next step. Move to the step number 2. Step 2. Okay. So in the step 2, we have to compute and simplify g composed with f. Compute and simplify g composed with f. Now, if this is not equal to x, then g is not the inverse. If it's equal to x, then yes, then g would be the inverse of f. So if it's equal to x, then g is the inverse of f. The inverse of f, yes. All right. So basically, the 2 steps are, so first step, you compute f composed with g. If it's not equal to x, then you can stop there and you say g is not the inverse. If it's equal to x, then you have to move to the next step and check g composed with f. If it's equal to x, then g is the inverse. Of course, if it's not equal to x, then g is not the inverse. Anyway, so our example here, we have this f, which is 5x minus 9. And we have this g, which is x plus 5 over 9. So let's do first the first step, which is just compute and simplify f of g. All right. So step 1. So I'm gonna write again the f was like 5x minus 9, and the g was like the x plus 5. The whole thing over 9, right? So we have, in the first step, we have to compute this f of g of x. So this is f of g of x, right? So in f, I have to substitute the x by g. So this x here by g, right? So we're gonna have like 5 times, and then the g, which is x plus 5 over 9. Right? And then there's this minus 9, right? There's this minus 9. Okay, so let's compute this thing. Well, so this is f of g of x. So we have to multiply by this 5. 5, this is like, you can make it like a fraction by dividing by 1. So this is like 5 over 1. And when you multiply, it's just so you multiply like a straight across, like 5 times x, 5 times x, that's 5x, plus 5 times 5, that would be 25, right? And in the bottom, it's just 1 times 9, right? It's just 9, minus 9. Okay, so, in other words, if you want to simplify this, so here, the whole thing is divided by 9, so we can divide this term by 9, all right? And this one here by 9. And this is divided by 9, and this thing here is also divided by 9. So it's like 5x over 9, which is 5 over 9x. And then plus, there's this plus here, 25 over 9, right? Minus 9. There's this minus 9, right? Anyway, so as you can see, guys, this is not, f of g of x. So that'll be equal to, so f of g of x, that'll be equal to, so this is 5 over 9 x. And here, we need the common denominator, right? We have a subtraction of fractions, because I can make 9 like a fraction, 9 over 1, right? And so we need the common denominator. Common denominator would be 9. We have to multiply by 9. So that would be like, plus 25 over 9, minus 9 times 9, that's 81 over 9. All right, and once you have a common denominator here, then you can subtract 25 minus 81. So this is equal to 5x over 9 plus, so you subtract, 25 minus 81, that will be, I guess, minus, of course, this is a minus, so minus 56, right? 56 over 9, right? 25 minus 81, that's minus 56, yeah, over 9. Anyway, so that's the final answer. I mean, there's nothing else we can do. Yes, Lisbeth.
Professor, for example, I saw that you put 1 in yellow.
Yes.
On 9.1, like you have to
Yes.
multiply. Where you found the 1?
Yeah, there's this.
Always you multiply by the number that you have on the bottom?
Yeah, so first, because, okay, let me just explain this again. So, so the idea is, you see this fraction here. Oh, sorry. So you see this fraction here, the 25 minus 9. Sorry, 25 over 9.
Yes.
Minus 9, which is a whole number. Okay, but so you have a fraction minus a whole number. So the way we do it is you make the whole number look like a fraction. Okay, so the 9, I just divide the 9 by 1, because anyway, 9 over 1, it's still 9, right? It doesn't change anything when you divide by 1. And now both, they look like a fractions, right? And both, now I have both are fractions now. Okay, and we're gonna subtract fractions. And the thing is, we don't have here, we need the common denominator. This is 9, as you can see, this is 9, right? And this is 1. So to get the common denominator, what you do, you cross multiply, like this 9 here times 1 here, and times this 9 here. And we are supposed to multiply like 1 here by this 25. Sorry, I'm gonna pick another color. So this 1 here times this 25 and times this 9. So it's like this 25 is supposed to be times 1. This 9 here is supposed to be times 1, right? And the other fraction, so multiplied by 9 here and multiplied by 9 here.
But we multiply for the same number.
Yes, yeah. When you, yeah.
If I have 8, I'm gonna multiply for 8.
Yes. Well, we multiply. You have to multiply and divide by the same number, of course.
Okay, thank you. That's my question.
So yeah, so I got this f of g of x, and obviously it's not equal to x, right? This is obviously not x. This is not x. Okay, so because it's not x, then we can stop here. We don't need to move to the next step. So this g is not the inverse of f. So then g of x, so the answer or conclusion here, so this g of x is not the inverse of f. Okay, because we simplified our answer and we didn't get x, right? So then g is not the inverse of f. All right, now let's do an example where g is going to be the inverse. Okay, so this is first example number 2. So let's take f of x. It's 4x minus 7, and g of x is x plus 7, the whole thing divided by 4. Okay, so first step, f of g. So this is f of g of x. So as you can see, so f of g of x, so which means we have to substitute this x by g, right? We have this x here, so the x becomes g, right? So this x here becomes g. So it's like now 4 times G, right? This is my G, 4 times G, which is, so what's G? Well, G is X plus 7, right? This is my G here, X plus 7 over 4, right? And then there's this minus 7. So here's minus 7. Now, guys, so let's try to simplify this thing. So this is f of G of X. So it's 4 times, and then this is X plus 7 over 4. Well, you can see here, guys, I mean, if you make this 4 look like a fraction, so this is like a 4 over 1. So as you can see, there's a 4, there's this 4 here in the, because of course there's a multiplication here, right? There's this 4 in the top, and there's this 4 in the denominator. And because we do have a multiplication, right? Then this 4 actually cancel out. Okay, I forgot the minus 7 is, of course, this is minus 7 here, right? So 4 cancel out. So that's just, it's just X plus 7 in the top, and in the denominator, it's just 1, right? So this is, so it's just a f of G of X. So it's a X plus 7, and there is over 1, just over 1, right? Because I got this 1 here. So it's just over 1 minus 7. Now, X plus 7 over 1, I mean, any number over 1 would be the same number, right? So X plus 7 over 1 would be just the same thing. So just X plus 7. And then there's this minus 7, right? And so the 7 cancel out. So this is 7 minus 7. So the answer is X. So because we got X, then we have to move to the next step, step 2, right? So move to the step number 2. Now, in the step number 2, because we got X. So in the step number 2, we have to check G of f of X, G composed with F. So step number 2.
What was that?
Yes.
What was that about the number 1 you said? What?
Number 1?
All right.
Oh,
So,
yeah. But, yeah, I was saying any number. I was saying like any number divided by 1 would be the same number. Like if you divide 5 by 1,
right.
it would be 5, right? So you have X plus 7 over 1. So it's going to be also X. It's going to be X plus 7, right? Yeah.
okay, I see now.
So now we move to the next step number 2. So in the step number 2, we have to evaluate and simplify G of composed with F. So it's G now first, composed with F. And as you know, guys, I mean, in general, F composed with G is different from G composed with F, right? In general, okay? Because, excuse me, is it someone said something? Probably not. Okay, so so this is G of f of X, right? So now let me just write down here for you guys. I mean, G of X was like X plus 7 over 4, right? That's my G of X. And what we need to do is we need to substitute this X, as you can see, this X with this f of X now, right? This X now becomes f of X. So there's an X here in the top. So this X here becomes F. So now, so that's equal to, so F, what's F? Well, F is this 4x minus 7, right? So we have this 4x minus 7, and then there is this plus 7, right? We are in G, right? So there's this plus 7, so there's plus 7 here, and the whole thing divided by 4. Divided by 4. And again, this is the X becomes f of X, right? This is my f of X. All right, so let's try to simplify this thing. So this is G composed with F. Okay, so we have to simplify the top first. There is this, as you can see, there's this minus 7 plus 7. cancel out. So now it's just 4x over 4. And then, of course, 4 over 4 cancel out. So the answer is actually equal to x. So as you can see, guys, both f of g of x and g of f of x, both are equal to x. So then we can conclude that g is the inverse of f. So, so conclusion is that so f, yes, Lisbeth.
Sorry, Professor, because I was writing down the exercise.
Yes.
For example, we talk like x plus 7 minus 7, and that's our dx, and then we do the problem.
Sorry, I didn't.
For
Can you
example,
repeat? Yes.
if you say x plus 4, sorry, plus 7,
Yes.
we talk that from the from our last solution, that is x, and then we solve that problem.
No. So yeah, I was saying yeah. So if we get x in the first step, if we get x in the first step, then yes, we move to the second step. This one here, and then
and with the same letter, like x plus 7.
yeah, the x plus 7, the x plus. Yeah, the x plus 7 over 4, that's my g of x, right? That's my g of x. That's given. It's given in the problem, right? That's my, as you can see here, it's my original or my initial function g, right? That's my function g, the x plus 7 over 4. And what I want to do in the second step, I want to compute g not of x, but g of f of x. So which means that I have to replace, you see this x, I have to replace the x with f of x. So there's an x in here, you see this x now becomes f of x. So that's what I did in the second step.
Okay.
Okay.
Thank you.
I hope this answers your question. Yeah, so in both steps, we got x, exactly x as the answer. So f of g of x is equal to g of f of x, and so both are equal to x. Okay, so then g of x is the inverse of f. Okay. So whenever you have to determine whether a function is the inverse, whether a function g is the inverse of f, so there are two steps, right? You compute f of g. If it's x, you move to the next step where you compute g composed with f. But of course, if it's not equal to x, then g is not the inverse. Before the exercise, guys, let me just remark one thing. So here in this example, we just said, so here my f was like 4x minus 7, right? And my g was like x plus 7 over 4. As you can see, guys, so g, of course, here we said, so g is the inverse of f. Is the inverse of f. So as you can see, guys, here, I mean, the g is not like it's not like a reciprocal of f, right? This is not 1 over f, right? It's not 1 over f. I mean, 1 over f would be like 1 over 4x minus 7, right? So obviously g is not 1 over f. And however, you can see if you make some, let me just make a table of values of f. So for example, here, let's say this is x and this is f of x, which is for x minus 7, of course. So for example, if you say, let's say x is 0. So what will be f of 0? Well, f of 0, 4 times 0 minus 7, f of 0 would be negative 7, right? If you take, let's say x equal to 1, what will be f of 1? f of 1 would be like 4 minus 7 will be negative 3, right? And let me just take a last value of x. I'm just taking some random values. I'm going to show you something. So if x is 2, then f of 2 would be 4 times 2, which is 8 minus 7, which is positive 1, right? Now, if I make a table of values of with g, okay, and what I'm going to do for x, I'm going to, of course, g is x plus 7 over 4, right? That's my g. So what I'm going to do, I'm going to, for x, I'm going to take these values for x. So this is minus 7 here, minus 3, positive 1. So you see here, this is the values of f of x. So I'm going to take these values as the values of x here. So I'm going to take minus 7, negative 3, and positive 1. All right, so if x is negative 7, what will be g of negative 7? Well, you just replace this x by negative 7, right? So negative 7 plus, negative 7 plus, so it's like negative 7 plus 7 over 4, right? That's my g. So a negative 7 plus 7, of course, is 0, and 0 over 4 will be 0. So the answer here is 0. So as you can see here, the answer 0, it's the same as the input x here. Now, if my x is negative 3, what will be the g of negative 3? Well, g of negative 3 would be like negative 3 plus 7 over 4. Negative 3 plus 7, that would be positive 4. And positive 4 over 4 would be positive 1. So the answer here would be positive 1. And that's exactly the input x here, right? And finally, if your x is 1, so then 1 plus 7 over 4 will be 8 over 4. And so the answer will be 2, which is the same as my x here. So what I'm saying, guys, is that, as you can see, this is why the g is the inverse of f. So if f of 0 is negative 7, then g of negative 7 would be 0. F of 1, we said it's negative 3, right? Then, as you can see, g of negative 3 would be positive 1, right? And f of 2, it's positive 1. Then g of 1, it's actually positive 2. So that's what the inverse does, right? So you in some sense you switch the x with the input x with the output y, right? So it's like here, f of 0 is negative 7. F of 0 is negative 7, so negative 3. So then f g, which is the inverse of f, g of negative 7 would be 0. Right? Etc. So like here, f of 1 is negative 3. Then the inverse, so if you find the inverse, which is g actually, so then g of negative 3 would be positive 1. Right? Yeah, so anyway, so yeah, as I said, so this g is the inverse of f, and of course this g is just we can denote this g by f with the power negative 1, because it's the inverse of f. That's the notation from for the inverse. All right, guys, is there any question before the exercise? All right, so here's an exercise, and so you have to determine whether whether g is the inverse of f. So exercise. And after this exercise, I'm going to show you guys in general how to find the inverse of a function, right? So in this exercise, we have to check, determine whether G is the inverse of F. Okay. So for number one, let's say number two, and let's say number three here. All right, so let's see. For number one, f of x is 2x minus 7, and g is 4x minus 2. Right. Number two, f of x is 4 over x plus 9, and g of x is actually 4 over x minus 9. All right, and then last one, let's say f is 3x minus 5, and g is x plus 5, the whole thing divided by 3. Okay. All right, guys, so let's say you have 10 minutes to think about this exercise. Yes, I think you're correct. Rabiul, first one is not, G is not the inverse of F. Yes. 2 and 3 Xing, you're saying the inverse. Yes, I think you're absolutely right. Yes, very good, Xing. Yeah, that's absolutely right. Yes, for number 2, Rabiu. Well, actually, as I said, you have to check two things. You have to check f of g and also g of f, right? So if you get f of g in the first step, like f of g of x equal to x, so that's not enough to conclude that g is the inverse of f. You have to check, the g composed with f is also equal to x. So Elizabeth. Yeah, actually, number 2 is gonna be the inverse. You're right. Yeah. So please, guys, don't forget your homework number 3. It's uh, it's due tonight before midnight. And as I said, I mean, the homeworks are kind of important because I'm gonna have similar problems in the tests. So if you do the homeworks, uh, it should be fine for the test. All right. And yes, number 3 is G is gonna be the inverse. Yes, absolutely. Yeah. Yes, Elizabeth. Number 3, it's yeah, G is gonna be the inverse of F. So again, guys, this inverse is not the inverse of the function f. It's not like the reciprocal of the function f. It's not 1 over f, right? It's really something else. So it's just a function which switch, as you can see here, switch the input x with the output y, right? So for example, here the input x is 0, then I got -7 as the output. Now, if my input is -7 in the inverse, then the output would be 0, right? So it switched the input with the output. That's what the inverse does. Right? Does anyone need more time? Okay, probably not. Well, then, so let me go over this exercise. And as I said, after this exercise, Sean, yes, very good, Sean. Yeah, first it's not the inverse, and second and the third, G would be the inverse of F. Yes, very good, Sean. So as I said, after this exercise, I'm gonna show you guys how to find the inverse of a function, right? So here I have two functions, f and g, and all I'm doing here, I'm just trying to see if the g is the inverse of f, okay? But so later, after this exercise, I'm gonna show you how to find, given a function f, a random function f, I'm gonna show you how to find the inverse g of f. Anyway, so yeah, so let's go over this exercise. So for number one, step one, so we have to check f of g of x, or f composed with g. So we need to substitute this x with the g. So this x here with the g. So that will be 2 times g. So 2 times 4x minus 2, right? That's my g of x. And then there is this, there's this minus 7. So here's my minus 7. So f of g of x, sorry. So it's 2 times, 2 times, sorry guys. So 2 times parentheses, so 4 minus x minus 2, minus 7. So that will be equal to, so f of g of x. So that's 2 times 4x, that's 8x. 2 times 2, there's a minus sign here, so that's minus 4. And then there's this minus 7, of course, so it's minus 7. So this is 8x minus actually 11, okay? And obviously this is not equal to x. There's no way that this is equal to x. This is not x. And so we can just stop here and say that g of x is not the inverse of f. Okay. All right, so for number 2, please let me know, guys, if you have any question. Please don't be shy, feel free to ask any question, all right? So for number 2, so step 1, this is f of g of x. It's not f times g of x, it's really f of g of x. So we have to substitute this x, as you can see, with the g. So there's an x in here, right? So we have to substitute this x with the g. Here's my g, right? This whole thing is my g. So it's actually 4 over, this is 4 here, right? Over the g, which is 4 over x minus 9. And there is this, so this is 4 here in the top, divided by 4 over x minus 9, and then there's plus 9. All right, so here, guys, just be careful. There's this 4, this is whole number 4, divided by this fraction, which is 4 over x minus 9. So my advice for you guys, if you have like a division or multiplication and one of the term is a fraction, my advice is to make the other one look like a fraction. So like this 4, I would just divide it by 1, because anyway, 4 over 1 is still 4. So now it looks like a fraction, and now like we have like division of two fractions, right? So when you divide two fractions, you flip the one in the denominator. So you flip this one here. All right, so this is just, so f of g of x, it's like 4/1, right? My whole number 4 divided by 1, and I flip this x minus 9/4. Right, and then of course this is plus 9. So here's plus 9. All right, so let's try to simplify this. We have a multiplication, which is good news, because if you have a multiplication of fractions, so then you can simplify, right? So there's this 4 here in the top, cancel out. So this is just now, so f of g of x, it's just now x minus 9 over, and there's 1 here, so over 1, and there's plus 9. Now, of course, x minus 9/1, any number over 1 would be just the same number. So x minus 9/1 would be x minus 9. And then there's plus 9, of course. So plus 9. And as you can see, 9 cancel out. And so the answer is x. And that's exactly what we need, right? That's as I said, so you get x here. You cannot really conclude that g is inverse of f. We need to check g composed with f. So that we need to move to the step number 2, where you evaluate g of f of x. So this is different from the first step, right? The first step was like f of g. The second step is it's actually g of f. So that's different. I mean, in general, they are different. So let's see. What will be this g of f? So what's g? Well, let me just write it down for you here again. So g is 4 over x minus 9, right? That's my g. That's my original function g. And so we have to substitute now the x with f, right? As you can see, the x now becomes f. So this x here becomes f. So it's now 4 over, so what's f? Well, it's, so let's see what's f. F is, here's my f, it's 4 over x plus 9. It's 4 over x plus 9. So f is 4 over x plus 9, right? That's my f. And then there is this minus 9, right, in g. So there's a minus 9. All right, so that will be equal to, well, in the top, it's just 4. In the denominator, we have this plus 9 minus 9. Oops. So in the denominator, we have this plus 9 minus 9, so it cancels out. So it's just 4 over this 4 over x. So in the top, it's just a whole number. And in the denominator, it's a fraction. So I'm going to make the top look like a fraction. So I'm going to divide this 4 by 1, right? 4 over 1, it's 4 anyway. And so we flip the denominator. So that's 4 over 1 times x over 4. And as I said, this is just so we have multiplication. So then you can cancel out this 4. So it's just x over 1, and x over 1, of course, is just x. So g of f of x, it's x over 1, which is, of course, equal to x. So the answer is also x for g composed with f. Okay, so for both, for step 1, f of g is x, and the step 2, g of f is also x. So both are equal to x. So then yes, then g is the inverse of f. So conclusion. Conclusion. G of x is the inverse of f. Any question, guys? Otherwise, let's move to the number 3, last problem, number 3. So in number 3, we have 3x minus 5. So for number 3, I'm gonna write down again the f and g because now it's like I guess 3x minus 5, and g is we said is actually x plus 5 over 3. All right, so let's see. Step 1 should be f of g. So this x here becomes g, right? So this is equal to 3 times the g, which is x plus 5 over 3. And then there's minus 5, minus 5. And so let's simplify this thing. Well, as usual, so again, my advice is just to make this whole number as a fraction. So we have multiplication of 2 fractions. And now because we have a product, see here we have a product, there's this number in the top, and there's there's a 3 in the top, there's a 3 in the bottom, so they cancel out. So now it's just x plus 5 in the top, and it's just 1 in the bottom. So this is minus 5. Of course, this is minus 5. So x plus 5 over 1, again, it's just x plus 5, minus 5, and the 5 cancel out. So the answer is x. Okay, that's a good news because we can move to this in step number 2. So in the step number 2, so we have to check now g of f of x, which is again different from f of g in general. So let's see. So this is my g of x, and I have to substitute this x with the f, right? And I have an x here in the top. So this x now become a f. So it's just now, so f, what's f? F is 3x minus 5, right? This is my f. So it's 3x minus 5. And then, as you can see, there's this plus 5 here, right? So this is plus 5 here in g, and we divide by 3. So we divide by 3. So 5 cancel out, minus plus 5. So it's just now 3x over 3, sorry. 3, and of course, 3 in the top, 3 in the bottom. So then it cancel out. So the answer is just x again. Right, so I got x in the first step, I got x in the second step. So conclusion is that g is the inverse of f. All right. Any questions, guys? Now, so next, next, the big question is, how do we find the inverse in general? So given a random function f, right? How do you find the inverse? So, so now the question is, so given f of x, right? How do we find the inverse? And as I said, the inverse is not like just a reciprocal, right? It's not like just 1 over f. So given f, how do we find g of x, the inverse? I mean, of course, how do you find the inverse of f of x? Okay. So I'm going to show you with an example how we find the inverse. So I'm going to just make like a table with the example and the steps. So here's the steps. And here's my example. Okay. So let's say my f of x is, so I'm taking a random f. Sorry. So f of x is, let's say, 2x minus 7. Okay. And of course, the goal here is to find the inverse of f, right? So that's what I want to do. I want to find the inverse of f. So step one, first thing to do is just to substitute f of x, or replace f of x by y. By y. Okay, so what I'm saying is that this f of x, I'm gonna just replace this f of x by y, right? So now we have like y equal to 2x minus 7. Step number 2, I'm gonna interchange x and y. Interchange x and y. Right? So what do I mean by interchange x and y? I mean y becomes x, so this y here becomes x equal to 2, and x becomes y. So this x here becomes y minus 7. Right? And the last step, we have to solve for y, and that will be your inverse function. So solve for y, and the inverse function f minus f of power -1 of x, the inverse function, that will be the y. Okay. So again, we need to solve for y, guys. It's not for x. I mean, I know x is equal to y minus 7, but we need to solve for y. Okay. So here's my y. I want to solve for y. I'm gonna, well, get rid of the 7 here. This is plus 7. So plus 7 here, both sides. So this is x plus 7 equal to y, right? This minus 7 plus 7, they cancel out. And now I'm going to divide by, it's 2y. So I'm going to divide by 2, both sides. And so if you divide by 2, of course, then you get your solution. So then y would be equal to x plus 7, the whole thing divided by 2. So the answer is that the inverse, so the inverse function, the inverse of f, the inverse function is equal to the x plus 7 over 2, right? So what I'm saying is that this is, so this function here, the x plus 7 over 2, is the inverse of this 2x minus 7. Okay. Any question about these steps, guys? So you take your function f, right? Replace f of x by y. Interchange x and y, and then you have to solve for y. Now, before the example or the exercise, there is one problem with the steps. Actually, you may have a problem with the third step, okay? Because in the third step, we are supposed to solve for y, but the thing is, we cannot always be able to solve for y, okay? So we cannot always solve for y. That's so there's a problem here. So there is a problem with the step number 3. So we cannot always we won't be able always to solve for y. Okay, so we cannot always solve for y. Let me give you an example where we cannot solve for y. I mean, very, very stupid, very simple example. Here's an example. Well, I'm gonna give you two examples. So example one, let's just take f of x is equal to just a constant, okay, equal to 2. So when I say f of x is equal to 2, it means that the output y is always 2. It doesn't matter what's the input x. It doesn't matter x, the answer or the output is always 2. So that's what I call the constant function. So let's say just f of x is equal to 2. Okay, for any x, the output y is equal to 2. So if I follow the steps, first I said you replace f of x by y, right? So this f of x here becomes y. So now it's like y is equal to 2, right? And then you're supposed to interchange x and y. So y becomes x. So this y here becomes x, and x becomes y. But there's no x, right? So it's just x equal to 2, right? But then you're supposed to solve for y, but there's no y. Okay, so yeah, well, because there's no y, we cannot really solve for y. All right, so we can't solve for y because there's no y, obviously. So we cannot solve for y. So this function f for y. So f of x is equal to 2, which is a constant function, a very simple function. It doesn't have an inverse. So f of x equal to 2, it doesn't have an inverse. So what you have to keep in mind, guys, Rabiul, you had the question. No, it doesn't. No. If you have a constant, like you're saying, like if you have like a constant function like x plus 2, I mean, it doesn't mean anything. The constant here, what I'm saying is that if the function is equal to just a constant, there's only a constant in the function, then yes, then the function doesn't have an inverse. But if you have like, I don't know, like x squared plus 2 or x plus 2, you have to, you cannot really conclude anything. You have to follow the steps and see if the function has an inverse. Okay, I guess that answers your question. So having a constant in the function doesn't mean anything, but if you have only a constant, like here, like I have only a constant, there's no x, then yes, then your function doesn't have an inverse. So what you have to keep in mind, guys, is that not all the functions have an inverse. Okay, like this in this example, this function obviously doesn't have an inverse. So not all the functions have an inverse. And let me give you another example. Example number 2. So let's say f of x is equal to x squared. Okay, so as usual, you're supposed to replace f with y. So y is equal to x squared, right? And then you're supposed to interchange x and y. So this y becomes x and equal to, and this x becomes y, right? So it's y squared now, right? X is equal to y squared. And then you're supposed to solve for y. So if you solve for y, you have x is equal to y squared. Because to get rid of the square, you apply square root, right? You apply square root here, and there's a square root here. But because the power is even, then you need the plus or minus, right? So then the answer is, so in this case, y would be equal to plus or minus square root of x. Okay, but well, this is supposed to be the inverse, but this is not a function. Remember, guys, y equal plus or minus square root of x, because because of the plus or minus, you have two possible outputs. This is not a function. This is not a function because we have two possible outputs or two possible answers. It's not a function. So in this case, because this is supposed to be my inverse, right? This is supposed to be my inverse, but this is not a function. So in this case, this f of x, it doesn't have an inverse. So f of x equal to x squared, it doesn't have an inverse. Okay, I mean, so your answer, when you solve for y, your answer must be a function, like in the example we had earlier. So like here, I got this y equal to x plus 7/2, and obviously x plus 7/2, it's a function, right? There's no problem with that. So yeah, so sometimes you cannot solve for y, and sometimes you solve for y, but your solution is not, it's not actually a function, right? So then if the function f doesn't have an inverse. All right, guys, is there any question? So let me just write down here as a remark, not all the functions have an inverse. So not all functions have an inverse.
Any plus or minus is not a function.
Yes, because of plus or minus. Remember, in order to be a function for each input, there is exactly one output, but because of a plus or minus, there are two possible outputs. So this is not a function. I mean, y is not a function of x.
Whenever you get a plus minus, it's not
Yeah, it's not. Whenever you get plus or minus, it's not a function. Is this the only way that there won't be an inverse? Yeah, as I said, well, there's this way where you end up with like a plus or minus, or sometimes, as I said, you can just you cannot solve for y. Sometimes it's not possible to solve for y, right? Like here, as I said, we cannot solve for y. Sometimes you are able to solve for y, but you end up with something which is not a function because of plus or minus. So it depends on the problem. But all you have to do, guys, of course, try to follow these steps here, right? Replace f of x by y, interchange x and y, solve for y, and then if you are able to solve for y, you have to make sure that your answer is a function, right? All right, so here's an exercise. I'm gonna give you a couple of functions, and then you have to find the inverse. So exercise. So please try to find the inverse. I mean, if it's possible, of course, find the inverse of let's see. So let's start with some simple example. I mean, simple function, the x plus 1. More complicated, f of x equal to 4/x plus 1. And even more complicated, f of x is, let's say, 5x over 1 plus x. Right, so just be careful here. This is a plus 4/x, right? And then there's this plus 1 here. All right, guys, I'm gonna give you, let's say, 10 minutes to think about this exercise. After this exercise, I'm gonna show you the graph. So you have a function f given by a graph, and I'm gonna explain how from a graph you can tell whether f has an inverse or not. Okay, but let's first do this exercise.
Professor,
Yes.
Hi, it's Giovanna again.
Yeah.
I have a question about number 3 in the homework, in the third homework.
Yes.
On the part 2, you see how the fx and the gx are like kind of fractions. They look like fractions.
Yeah, both are fractions. Yes.
So
Yes.
how do you input that? Like,
Yeah. So
it was easier the first one, but now the second one, I'm like, huh?
yeah. I mean, I know. I mean, I think someone else asked me the same question at the beginning of the lecture, but so you have like this f of x. I'm gonna change the f of x. I mean, it's
Okay.
let's say like 2 plus x over I don't know, I say 3 minus x, and g instead of 4 over x, I'm gonna say, well, let's take 5 over x. All right.
Mhm.
Anyway, so I guess you have to find this f of g.
Mhm.
Right. So as you can see, so there's this x in here in f, and there's an x in here in f. So we have to replace this x with the g, right? This x here with the g and this x with the g. So it should be like 2 plus and then g, which is like 5 over x. And the same in the denominator, like you have like 3 minus, and again, this 5 over x. But now you have to, you see, like in the top, you have this whole number 2 plus a fraction 5 over x, right? So what I'm gonna do, because I'm gonna make the 2, which is a whole number, look like a fraction. So I'm gonna divide by 1. And the reason is,
Oh, you have
you
to.
need to come in,
Okay.
yeah, you
Yes.
need a,
Okay. Okay.
okay.
Yeah. Sorry, I haven't done math in a while, so I forget these little
Okay.
rules. Okay.
Okay. So you need the common denominator. You need the common denominator. All right. You need the common denominator, and then
Simplify and then.
simplify.
Okay.
Yeah.
Yep.
Mhm.
All right. Thank you.
Sure. I think someone. Let me see. Elian is the first one. X minus 1 over 3. X minus 1 over 3. Yes, Elian, you have a correct answer. Elizabeth, you're saying yes, you have the correct answer, Elizabeth, too. Yeah. Yeah, both of you guys are correct. So for number 1 should be x minus 3, the whole thing over 3, or sorry, x minus 1, the whole thing over 3, or you can say like x over 3 minus 1/3. Yeah. Number 2, Elizabeth, you're saying. For number 2, chat. 4 over x minus 1. No, I don't think. No, I don't think. I think it's incorrect. It's not. It's not 4 over x. No, wait. You mean like 4 divided by x minus 1, the whole x minus. Oh, okay.
Minus
Oh
Yeah.
yeah, I think you're correct.
The
Yes,
second one.
yes, yes.
I'm correct or no?
Yeah, you are correct. Yes.
Okay.
I'm sorry.
No.
I thought it was just a 4 over x.
No.
But yeah, you're correct. No.
Okay. Thank you.
Yeah, very good. Yeah, very good.
Thank you.
Mhm. Number 3, last one. I don't, Elizabeth, I think it's incorrect. I think it's incorrect. Yeah, I think it's incorrect. Mm-hmm. Well, I mean, yeah. Did you write something, Xing? I didn't. Where is your answer, Xing? I don't see it. It's not in the chat. I don't think you wrote something in the chat.
Yeah, we have the almost the same, but she has parentheses, and I didn't put parentheses. She wrote first than me.
Oh, okay. Oh, yeah, right. Sorry. Yeah, I see it now. Sorry. You're saying so it's x minus 5 over 1 minus x. Well, his denominator is 1 minus x. Well, I'm not sure. I think there's a problem. I'm not sure, but I think there's a problem with the sign. I have to check it. I mean, I have to solve the problem. I mean, I don't know the answer. I mean, I don't have the answer, but I think there's a problem with the sign. Let me see. So you're saying 1 over x. Well, I have to check. I'm not sure about the sign. I think it's correct, but Xing, I think it's correct, but I have to do it. There's probably a problem with the sign. All right, guys. I mean, we have like yes. So I think so. Some of you said like denominator it's 1 plus x, and I see like there are answers with 1 minus x. The Zoom user. Who's the Zoom user? I think it's I'm not sure is the Melody. Oh, okay. Yeah, Melody. I think yeah, probably your answer is correct. I think your answer is correct. It's the same as Xing. Well, Xing said the 1 minus x, and you said 1 plus x. I think it's gonna be 1 plus x, but I have to check. But I think it's correct. Yeah, I think Melody, your answer is correct. All right, guys. I mean, anyway, we have like 9 minutes. So I guess that will be, hopefully it's gonna be enough to go over this exercise. And then next time I will try to finish this section with the graphs, and then we can move to the next one. All right, so in the last 9 minutes, so let's do this. So for number 1, so I'm gonna follow the steps, right? So first, I'm gonna just write down the function f of x, which is 3x plus 1. As I said, just replace the f with the y. That's 3x plus 1. Now you have to change x and y. So that will be So this is now x, and this one here is now y. So it's x 3y plus 1. Now you solve for y. So you subtract 1 here, both sides. So now it's like x minus 3 equal to 3y. And then you divide by 3. So over 3 here and over 3 here. So then there's 3 cancel out. So now, so the answer, and I think all of you got this answer. So then y, it's x minus 3, the whole thing divided by 3. So that's the inverse, right? So the answer, so f inverse, or f to the power -1, it's x minus 1 over 3, right? That's the inverse. I think all of you got this answer, right? Number 2, it's 4 over x plus 1. So 4 over x so f of x, it's 4 over x plus 1. So this x, f of x, replace f of x by y. It's 4 over x plus 1. And now it to change x and y. So this y becomes x, and this x becomes y. So it's x equal to 4 over y, right? Plus 1. Now you have to be careful here, guys, because there's a kind of problem here, because I want to solve for y now, of course. But the thing is, y is in the denominator, right? It's not in the top, it's in the denominator. So anyway, so I want to solve for y. So first thing, of course, would be to just get rid of this plus 1. Just subtract 1. X minus 1. Sorry, it's x minus 1 equal to 4 over y. And as I said, the problem here is that my y is in the denominator, right? I want to solve for y. So of course, the idea now is to move the y to the top. So we need to move y to the top, right? And to the top. So the way to move the y to the top is actually to flip the fraction, right? So if you flip 4 over y, that will be y over 4. But if you flip the fraction on the right side, you have also to flip the fraction on the left side. Yeah, take reciprocals, Lorden, absolutely. Yeah, so you have to take the reciprocals, absolutely. So now reciprocal of x minus 1. So I mean, x minus 1, as I said, it's not a fraction, but if you want to make it look like a fraction, you can just divide by 1, right? Because whenever you divide by 1, it's just you get the same thing. It doesn't change anything when you divide by 1. So if you flip both fractions, so flip both sides, so that'll be 1 over x minus 1 on the left, and on the right will be y over 4. Okay, so I just flipped, or I took the reciprocal of the two fractions. Now, well, now my y is in the top. That's the good news. I have to get rid of this 4 in the denominator. So here we divide by 4. So the opposite operation, the division by 4, would be the multiplication by 4. So I need to multiply by 4 and do the same, of course, on the other side, right? Because I'm dividing by 4, so the opposite operation would be multiplying by 4. And so then multiply by 4, divide by 4, then the 4 would cancel out. So then y, so it's just now y on the right side. So y is equal to, and here, as I said, this is 4 times. I mean, this is, again, it's like 4 over 1, if you want to make it look like a fraction. And we are multiplying two fractions, right? So it's you multiply straight across. So this is like 4 times 1, which is 4, right? There's 4 here times 1, and this is 1 times x minus 1. So 4 times 1 is 4 in the top, and 1 times x minus 1, it's just x minus 1. So that would be the inverse function. So, so the answer F inverse, it's 4 over x minus 1. All right, and last, so number 3 and last one in the last 3 minutes. Number 3. So number 3 was like f of x, which is 5 minus x over 1 plus x. So 5 minus x over 1 plus x, 5 minus x over 1 plus x. So as usual, this is y now. 5 minus x over 1 plus x. And then interchange y and x. So this is y becomes x, and the x becomes y. So it's now 5 minus 1 plus y. This is now. Okay, so I interchange x and y. Now I have to solve for y. Okay. Well, how do we solve for y? In this case, there's a problem here. The big problem is that y, it's actually in the top and in the, in the numerator and in the denominator, right? So even if you flip, if you take the reciprocal, you still have like a y in the top and y in the bottom. So it doesn't change anything if you take the reciprocal, right? So the idea here, guys, is to try to cross multiply, and so cross multiply and then solve for y. So what do I mean by cross multiply? Well, there's a fraction on the right side. On the left, it's just x, but as I said, I can make x look like a fraction. So this is like x over 1. And what I'm saying is that so when you cross multiply, so the x by the 1 plus y, so it's going to be equal to this one here times this 5 minus y. All right. So this is actually a very general fact. So if you have two fractions, two equal fractions, like let's say 2 over 4, which is of course 1/2. So if you multiply, cross multiply, you can see like 2 times 2, right, would be equal to 1 times 4. All right. So yeah, so why do we cross multiply? That's because when you cross multiply, then you have a chance to solve for y. Because when you cross multiply, the y is going to move to the top. So let me show you. So if you multiply, cross multiply, so x times the 1 plus y on the left, and on the right, it's like 1 times 5 minus y, right? So as you can see now, because I cross multiply, both y's are in the top. There's no y like in the denominator, right? So both are in the top. So now it's like on the left you distribute, so it's x times 1 plus x times y, and on the left it's just 5 minus y. Okay, so what I'm gonna do, I'm gonna move all the y's to the same side and everything else to the other side. So as you can see, guys, for example, there's this xy on the left, so I'm gonna move it to the right side, and there's this 5 on the right side. I'm gonna move to the left. So the idea is I'm gonna move all the y's on the right and everything else to the left. So so what I'm gonna do, I'm gonna like subtract 5, both sides, of course, and I'm gonna subtract this x minus xy, both sides, and I'm going over time. Do you have time? We have, well, no, I think probably I should stop. You know what, guys? I'll continue with this next time. All right. So I'm gonna stop here because I'm gonna need like another 5 minutes. and already like I took like 2 extra minutes already. So yeah, so I'm gonna stop here, guys, and I will continue with this tomorrow. Okay. Thank you, everyone. Have a good night, and please don't forget your homework for tonight. Thank you, everyone. Take care. Good night. Thank you, everyone. Bye. See you.
Good night. Good night.
Good night. Take
Wait,
care.
Professor, I have a question
Yes.
on the homework, remember?
Mhm. Yes, I
I
remember.
leave it. Okay,
Yeah.
so it's just quick. I know you told me that 0, I apologize about the noise.
No
That
problem.
infinity is
I'm gonna just stop recording.